everyone. Um, this is Kingsley, just Kingsley Naji. Um, it's been 4 years now, since the last video. I must start by apologizing sincerely to all of us for taking so long before doing this next video. I'd received a whole lot of calls and texts requesting for additional videos. Well, basically, I'm really very sorry for taking too long before doing this video. But to make up, I have actually decided to provide a lot more detailed information and to share quite a number of secrets, things that took me about so many years actually to learn. I remember when I started off this journey in learning PlanSwift, there wasn't really much online. I read books, watched a lot of videos, but sometimes you just make mistakes here and there, and then you learn with every mistake. So that has been the story so far, the journey so far. So I'm going to be sharing a lot of secrets that you might not readily find elsewhere. So I would encourage us to pay attention, listen carefully to everything I say on this video. By the end of, anyway, you can check the description column. I'll share some of the files I use, some of the files I've worked on, and even with the files, some of them I've made mistakes on before, but what I'm going to be sharing with us is documents that took years of practice and mistakes here and there, corrections upon corrections, to perfect these things. So it wasn't just something that just came up out of the blues in a day. This is decades of practice, that resulted into the document I'm going to be sharing here. So please, let's take these things very seriously. Sorry, I have a bit of a cold. Okay, so quickly, I believe we all, from the last tutorial video, anyone watching this video should know how to add drawings on PlanSwift and how to open new drawings on PlanSwift. So I'm not going to be talking about that, so I'm just going to be heading straight to what I promised us the last time. I said I was going to be doing a tutorial video, a proper video on how to do taking off PlanSwift for the foundation of a building. So you can see this building here. I'm going to be doing the taking off for this building on PlanSwift, but I'm just going to be working on the foundation only for this tutorial. Quickly, before I dive into this, I remember a number of times some persons have called me and they're like, bro, how are you able to prepare a build sometimes in less than an hour or 2 hours? How are you able to do it? Is it rocket science? Well, it's not magic. I don't guess. People that know me know I don't play around with taking off stuff. I don't guess with what I do. If I give you a quantity, you can be rest assured of the quantity, because I actually take my time to measure things properly. So even though I don't spend so much time doing it, doesn't mean I don't really take time to do the measurements. I do. But I'm going to be sharing the secrets, how you can start and finish your build, even your material and labor, in less than an hour for an entire build. So, but because this is a tutorial, so obviously this video is going to take, I don't know how long this video is going to take, but I just hope it doesn't take too long and we actually get to learn. Alright, so quickly, I'll dive into it. Now, um, preparing bill of quantities requires not just knowing how to do takeoffs, it also requires knowing how to work around Excel. So for the sake of this tutorial, you can see my Excel page here. I've prepared this Excel document. I'm going to be sharing this on the description, so just check down the description, you'll see it there. So like I said, this is a free giveaway. This document took years of practice and a lot of mistakes here and there, corrections here and there, before it became what it is now. So this is majorly what I use. So I do my takeoff in PlanSwift and then import them here on Excel. Yeah, maybe later on I'll do another tutorial video on how to link your PlanSwift and Excel together, such that when you're doing your taking off on PlanSwift, it's coming straight to your Excel. You don't have to import it here manually. But for the sake of this tutorial, I'm going to be doing this manually for those of us who don't know how to do it automatically. So you just follow up and then let's see where it goes. Alright, so quickly, like I said, I'll be doing the taking off for substructure, for all substructures for this particular building. So substructure, usually I'm going to be following the regular taking off format. That's starting with site preparation, trench excavation, pit excavation, earthwork support. So you're going to see that by the time I'm done doing my taking off here on this taking off sheet, it's going to reflect in my bill of quantities. You can see my bill of quantities it's already prepared, and at the same time it's going to reflect in the material and labor breakdown. So I'm going to be doing the bill together with the material and labor all at the same time. Yeah, somebody might say wow. Well, yeah, that's how it works. So this document, like I said, took a lot of time to prepare, and this is years of practice. Okay, so let's start. Going back to the taking off. So I'm starting with the site preparation. So I just go down to my PlanSwift. Site preparation requires that I maintain some working areas around. So I'm just going to click on the area tool. So you can see here, reminding me that I haven't scaled this drawing yet. So I'm going to scale it. So I look for a known dimension. For those who don't know how to scale, please check the first video and then you find out how to scale. So I'm going to scale using this one. So this is 6.46. Yeah. So take this here, take this there. Alright, so I'd like to delete this. Alright, so I'm done scaling this document. So from this I can get my site preparation. Yeah. Okay, so I just do a general, let me add working space. Just do it this way. Then I don't think I mentioned this in the last video. You can actually snap, just in case your snapping tool is off. You see, you have to turn it on. So once this is turned on, you can snap. I snap this point. She's going to change from red. To change from red to this color. So what snapping tool does is, you can see it helps me to maintain the cursor in this to follow this perfect line, this vertical line. So it's restrained to this vertical line. So it's also restrained to the horizontal line. Yeah, so that's what snapping does for me. So it just helps me find the perfect angles. So when I'm done doing my site preparation, I just hit escape. So with this, you can see here that my area is 421.19. Like I said, I'm doing this manually. 421.91. So you can see here, see, it calculates my area for me. So once this area is calculated 422, it reflects in my bill. You can see it here in the bill, 422. See it, it's already here in the bill. When I go to the material and labor, you can see it's already here in the material and labor, breaking it down. So that's how it works. So I go to the trench excavation. I want to close off this because it's blocking my view, so I just come here, turn off the lights here, so it's just gonna please pardon me if I'm a bit fast. I just don't want the video to be too long, so but you can pause, you can slow down the video anyway when you're watching, and in case it's too fast for you. Alright, so trench excavation, usually trench excavation is done in linear meters. So trench excavation. So when I'm done, when I type trench excavation, I come down to advanced. The width. So under this width, the width of my trench excavation, usually that's the width of 3 blocks put together. That's 675 millimeters. So if you convert that to meters, that's 0.675. So I type that in my under the width section, and then I press OK. So from this I can measure. You can see follows the line. So I'm done with this. I press new. As you can press N on your keyboard. See that snapping tool. See? So you can see this crosshairs. It's following me. Those dots, dot points like that. So so press new again. So once I measure, so I just press N on my keyboard, or I can use this one here, new. So it allows me to continue my measurements. Still measuring. So I like to be fast. I work with 2 hands. So okay. As you can see, I am done with measuring the trench excavation, so I can get the total perimeter of my trench from here. You can see it's 82.1. So I'll just go back to Excel and type 82.1. Okay, so I'll just delete these other ones. They are not necessary. So this refers to the width of my excavation. So the width of my excavation, like I said, is 0.675. Yeah, and then the depth of my excavation, let's say 1.2 for the depth of my excavation. So with this, I'm done with my trench. So you can see the total volume of my excavation is 67 cubic meters. So by the time you come to the main building, we check for under trench excavation, you can see it's 67. Likewise, the material and labor is also there, 67. So my pit excavation, let me delete this, it's not necessary. Alright, so the pit excavation is a little tricky. Yeah. Okay, so let's go to the pits. So this is my base. This is what the base looks like. I have just 2 bases here for this drawing. There are some drawings you'll be working on, and then you'd have up to some 15-20 bases. But for this drawing, I have just 2 here. I have just 2 bases. Alright, so for the first base 1, there are 13 numbers, and it's 1.4 by 1.4. So the length is 1.4, while the width is also 1.4. and then the total number is 13, so I'll write that under count. So please, when you're trying to make use of this Excel file, you need to be very careful to know what you need to touch and what you're not touching. So just follow the tutorials. Yeah. Alright, so 1.4 by 1.4 over there. My next base is this is 1.6 by 1.6. So 1.6 by 1.6, and the total number is 8. There are 8 of them. You can see it down here. So there are 8 of them, so I just type in that manually. Alright, so with this I am done with the calculations for my pit excavation. So the total volume is 55, as you can see. So that's the total volume for my pit excavation. And then straight down to earthwork support. So you can see earthwork support automatically calculates itself down here. I don't need to do anything here. Everything in my earthwork support is automatically calculated. I don't need to touch anything here. So likewise, the disposal tool calculates itself automatically. Don't need to touch anything here, except for the thickness of my base. Yep, the thickness of my base. So let me check how thick my base is. So my base, you can see this is 350 here. This is also 350. Then in addition to this 350, you can see that there's also another segment here. This is referring to the concrete cover here. So this concrete cover most times is 50. Or in case the structural engineer provides the details, please use whatever the structural engineer provides. But in this case, it's safe to assume that the concrete cover there is 50. So by the time you add 50 and 350, that's 400 for the thickness of my base. So meaning at this point I'd have to change this to 350, 0.35 plus 0.05 for my concrete cover. That altogether 0.4. So I'm done with this. Yeah. Now laterites. Yep. So I have to calculate my laterites. So I come back to this drawing. So this is blocking my view. So I turn it off. Yeah. Before I calculate laterite, I always like to do my block work first. So let me measure the block work. So block work, just like trench excavation, is also in linear meter. So the same way we did in the trench excavation, I just come under the width section. I change block work is usually 0.225. So that's 0.225. Yep. So I click on OK, and then I begin to do my taking off for my block work. So likewise, press new. I can snap to this point. It changes from red to white. So I also do this. Yep. So with this, I can snap to this point. So you see, it gives me a point. I don't have to stress about finding the exact location. So with this snapping, I just hover around. For you to snap, you just have to hover around without clicking. Just hover on the object, on the point, and to snap that point for you. So this is how it works. So I snap these 2 points, and then it gives me this point okay. And likewise. So that's how it works till you complete the entire. Alright, so you can see I'm done with the block work measurement. So I check here again to find out the total perimeter for my block work. So it's 115.5. So I just quickly type that into the block work. Where is it? Here. So 225 block work. So 115.5 I don't think I have any 150 walls there, so I'll quickly delete this. Yeah, so okay, so I'm done with the block work. Yeah, back to laterite. So laterite is usually in cubic meters, so I'm going to measure it here in square meters. So laterite excavation. Alright, so no, laterite, hold on, not laterite excavation, just laterite. So sorry. Alright, so this is laterite. Okay, so laterite is measured this way, you can see. So let's click on new after measuring that. So this is how it works. So basically, it's not as difficult as many people would think, that these things are so hard to learn and all of that. It's just don't really need to know so much about programming and all for you to be able to do this sort of stuff. Alright, so you can see I'm done with my laterite. So the total value for my laterite in square meters is 210.4 square meters. So I just impute that here, 210.4. So you can see it's calculated. So this is calculated based on the assumption that the thickness of my laterite is 0.2. That's 200 mm thick. And then you can see the hardcore 2 is also calculated here, also on the assumption that my hardcore is 300 mm thick, that's 0.3. So you can also still check the drawings to confirm, depending on the provisions from the structural engineer. So you can see here, it says here that the hardcore is 300 mm, but it didn't specify for the laterite. So you can decide to increase the thickness of your laterite here. Maybe if you want to increase it to 0.4, that's fine. But the hardcore from the drawing there is 0.3. So with this, it calculates the total volume for my laterite and my hardcore. So that's that for laterite, hardcore, surface treatment. You can see this is already calculated here for me. I don't have to touch anything here. So my surface treatment is calculated, same as my compacting, calculated, blinding, also calculated. The footing for my trench, you can see it's also calculated. Then the slab, my slab, the oversight concrete, yep, so I have to calculate this one. So my oversight concrete, to calculate it, I'd have to do it in square meters and then convert to cubic meters. So this is how we measure it. So I click on this point. Yep. So yep. Okay. So you have to be careful to measure the exact area where the slab covers. So you have to establish those points exactly where the slab covers. Right, so by the time I'm done, I just hit escape and voila, you can see, you can check it from here. Oh, I didn't even title it, so let me call that oversight. The oversight concrete. So my oversight concrete is 236.7 square meters. So I'd impute that here, 236.7 square meters under this area, and then perimeter, that's perimeter around the oversight concrete So let's check. So you can see the perimeter, the linear total is 67.75. So I just have to type that here, 67.75. So with this, I have successfully calculated my oversized concrete slab. So I don't have any ground beams there. I'd have to delete this. There's no ground beam there. There's no tie beam as well. My column base, you can see it's already calculated here, but the only thing that is not calculated is the reinforcement inside of it. So I need to calculate the reinforcements now. So let me check here. So the reinforcement inside is saying Y12, there are 10 numbers Y12. This one too, there are 10 numbers Y12, and the spacing is 150 center to center, 150 millimeters center to center. So this is the one I'm using. I'm going to cancel this. You see, this was calculated using Y20. So I'm just going to change my Y20 to times 0. See, so Y20 is gone. So I'm going to revert my calculations to the Y12. So from here it says the spacing is 150. So this is actually the spacing. So it's correct, 150. So if it had said 175, then we'll change this 150 to 0.175 here. Likewise, the vertical spacing is 150, the horizontal spacing is also 150. That's why I have this 2 here. I know these calculations might seem like jargons, yeah? I understand, but just in case you don't understand, you can still ask and I would explain further. So I draw this down. Yep, so you can see my Y12 is calculated. So I now come down to the bill to check, because the old bill, the bill I used as templates for this tutorial, you can see from here the column basis is calculated using Y20. So I have to change this Y20 to 12, and then for the quantities I'll now have to link this up to my Y12. I hope this won't be too difficult. See, I just linked it to my Y12. Likewise, I do the same for my material and labor. I scroll down to the place I just made that adjustment now. That's for this reinforcement. Yep, so there's no Y12 here, so I'd have to add Y12 manually. So I add that. Okay, so I have to change this to 12, change that to 12, and then likewise this is for Y16, so I'm going to change this to 0.888, which is the weighting factor for Y12. So click on enter, and then I have to link this. You see, it's still referring to the position for the Y16, so I have to change this, take this back to my Y12. Voila, see, it calculates. So also the cost too, I think Y12 is currently sold for about close around 13,000 or so now in the market. So well, let's leave it at 12,800, depending on TNT or whichever one you're going for. So that's that. Okay, this is good. Does this have any reference here to my Y12? It doesn't, so I have to add my Y12 here. So I add the Y12. Yep, so we're good. So we go back to taking off. So like I said, this document actually, it's not perfect yet, but we're getting there. Alright, so for me it just makes things faster and easier, a lot more faster and easier for me. Yeah, I don't expect that you guys will be able to learn or understand these documents just from one go. It will take some time and some level of practice to be able to understand this document and then find your way around it. Yeah. So I'm done with the column base. Now I'm going over to the column starters. So the column starters, these are from old files, so I have to delete these ones. They're from old files as well. Delete it. I'm working on that. Alright, so for my column starters, so I have to come back to the drawing to check. So I have two column starters, C1 and C2. C1 is 13 numbers, and this is the size of C1, 230 by 230. So I just come here, impute 230, that's for the length. The width is also 0.23, and then the number is 13. So likewise for my C2 is also 230 by 230, and the number is 8. So 0.23, 0.23, and total number is 8. So with this, I've calculated the volume of my concretes for the starters. I've also calculated the wall areas. This is for my formwork, and I've also been able to calculate. I'm going to calculate the reinforcements now. Now, from this, you can see that this is a previous calculation, and it was based on write-off for my column starters. But in this case, you can see here that what we have for this drawing is not Y25, is Y16, and they are just 4 numbers. So to correct that, I'm going to change this to 0. The numbers, I'm going to change this to 0. So by the time I change that to 0, I can just draw it down. Yeah, so everything there is 0. So I'm making use of Y16 now, and this 0 is going to be changed to 4. I'm changing it to 4. Why? Because this is 4. So I have 4 number Y16 here. So that's why I changed that to 4. So likewise for my second column, or the second column, there are 6 numbers of Y16. So I'm going to change, so this is for my second column. So I'm going to change this 0 to 6. See, that's simple. And we're done. Alright, we're done. So we just come down to bill and check. So you can see from the bill, this is saying Y25 for the column starters, and the second one Y20. So we're going to change this to Y16 because we are making reference to the 16 and not the 25 for this project. So I link that up with an equal to sign. So this is Y16, and I click on enter. Likewise, I do the same for the material and labor. For the material and labor, I'm just going to link it up. You can actually link your material and labor directly to the bill, but my material and labor is, in this case, is linked to my taking off and not the bill directly. So for my Y16, we're going to do this. Yep. So alright, so likewise, I do the same here. I'm going to add the Y16. Add it, yeah, no? Y16. Yep. Okay, so that's that. Okay. So we're done here for the column starters. My block work has already been calculated. I did that before. And then there's no ground beam, there's no 150 mm walls, there's no expansion joint, so I'm going to delete this. And that is it. We are done with substructure. All the substructural works we are done. You can see our bead is ready. You can see everything is calculated, giving us 29 million. Maybe because of this additional foundation. So if you like, you can delete. Excuse me, the additional foundation. Let's just make it yellow. So that's how it works. We have the bill ready, and we have the material and labor schedule also ready as well. So thank you so much, guys, for watching. So I'm going to do another video maybe soon enough on the other parts of the superstructure. We're going to look at the frames, we're going to look at the roof, how to measure roofs with PlanSwift, how to measure your beams and slabs and whatsoever. with PlanSwift. So thank you so much for watching, and see you guys next time. Bye.